We all live in a helical solar system. If this term sounds new, you're not alone. Most people don't know what it means. This video is an opportunity for you to learn that the helical solar system is where we all live. It will help you understand what a helical solar system is and show you how it moves. We live on planet Earth, one of the 8 planets revolving around a star we call the Sun. The Sun is one of millions of stars in the Milky Way galaxy. During the 20th century, astronomers discovered that the Sun itself is revolving around the center of the Milky Way galaxy. The Sun's velocity as it orbits the galaxy is currently calculated at 134 miles per second, or 482,000 miles per hour, a very substantial velocity. For centuries, we have been taught that the planets of the solar system move in flat orbits in a plane called the ecliptic, with the Sun at its center. All of that is still true, except for the term flat orbits. Since the Sun is moving through the Milky Way, then so are all the planets. When the sky is clear, we see the Sun during the day and the other planets at night. All of them where they should be, because we are all keeping pace with the Sun as it zips around the galaxy. Because the Sun moves, no planet can follow a flat orbit. To keep pace with the Sun, it has to move in a spiral, or a helix as the astronomers call it. Here we can begin to see the helical paths of each of the 4 inner planets as the Sun and planets move away from the camera. This video shows only the 4 inner planets because the 4 outer planets have diameters so wide that if we included them, the inner planets would shrink into an indistinguishable tangle at the center of the screen. The inner planets are much closer to the Sun, so by focusing on them, we can best demonstrate how helical orbits fit around the Sun. Moving outward from the Sun, we see Mercury, Venus, Earth, and Mars. We can also see that the planets closer to the Sun have to move faster than those farther out. This is so because the inner planets have shorter circumferences, and during any given time period must complete more orbits than those further out, which have longer circumferences. For instance, Mercury with the shortest circumference has to complete more than 8 orbits, while Mars is doing just 1 orbit. A side view of the helical orbits gives us an opportunity to see how the planets maintain uniform helical velocities that keep them aligned with the Sun's movements. A front view with the Sun and planets moving toward the camera confirms that uniformity of movement. Early in the 20th century, Albert Einstein developed the theory of general relativity, which was a new way of understanding how gravity works. In his theory, Einstein said that part of the effect of gravity was caused by a curvature of space around any massive body, like our Sun. Looking at the ghost trail of each planet, you can get some idea of what Einstein meant when he spoke about space being curved in the neighborhood of the Sun.